Alright, in this video we're going to find the empirical formula of a compound. So first thing we're going to do is we're going to assume a 100 gram sample. So we're going to assume that we have 100 grams of this particular compound. The reason why we assume 100 grams is because effectively when we do that we can take these percentages and just replace them with grams. So instead of 24.7% calcium, I know that this compound has 24.7 grams of calcium in it also. So there are four different elements. So let's just go ahead and write down the ones that I have. So it's 24.7 grams of calcium, and I have 1.2 grams of hydrogen, and I have 14.8 grams of carbon, and I have 59.3 grams of oxygen. Alright, so the next thing that we need to do is we need to get moles. So that's kind of the common factor in a lot of these problems, is you have to convert things to moles. So let's go ahead and convert grams of calcium into moles of calcium. Well, from the periodic table, I know that the molar mass of calcium is 40.08, and that's grams of calcium is in 1 mole of calcium. So I'm going to go ahead and set that up, and then I'll do the calculations here in just a minute. So in order to convert this to moles, I know that there's 1.008 grams of hydrogen in 1 mole of hydrogen. So now the fact that hydrogen is not by itself in this compound, meaning that I've got calcium, I've got carbon, and oxygen, I don't worry about the fact that hydrogen is diatomic, so I only have one H. So that's why the molar mass is 1.008 instead of double this. So hopefully that doesn't confuse you. And like I said, these numbers on the bottom, these are just the masses of the element. They come from the periodic table. So in order to convert this one, I'm going to say 12.011 grams of carbon is equal to 1 mole of carbon. So that'll be something we need to calculate. Now let's do oxygen. So there are 16 grams of oxygen in 1 mole of oxygen. Alright, so let's go ahead and get the calculator and figure out what we have. So let's calculate this, the calcium first. So we'll say 24.7 divided by 40.08, and that gives me 0.0616. We've got 3 decimal places, moles of calcium. So now let's do the hydrogen. So we'll take 1.2 divided by 1.008, and here I get 1.19 moles of hydrogen. And now let's do the carbon. 14.8 divided by 12.011, and I get 1.23 moles of carbon. And now let's calculate the oxygen, which is 59.3 divided by 16, and I get 3.70, we'll go 6. Okay, so this is moles of oxygen. So now what I've done is I've calculated all of my moles. Now, because empirical formula is basically the lowest whole number ratio of elements in a compound is the definition of an empirical formula, I need to get the ratio among these different moles. So in order to do that, and I'll switch colors here, so in order to do that, I need to divide these moles by the smallest number. So the smallest number here is 0.616. So if I divide 0.616 by 0.616, I'm going to get 1. So next thing I need to do is divide this number by 0.616, and let's go ahead and get that. So 1.19 divided by 0.616, that's going to give me 1.93, and which is really close to 2. So we'll keep that there. So 1.23, so once again I'm going to divide by the smallest number, which is 0.616. So then 1.23 divided by 0.616, and I get 1.99, which is really close to 2, so we'll call that 2. And here I'm going to divide this one again by 0.616. So 3.706 divided by 0.616, and that's going to give me 6.01, which is really, really, really close to 6. So now once again, let's choose a different color here. These numbers are the ratios among the elements in the compound. So this tells me how many of each element that I have. So I have 1 calcium, I have 2 hydrogens, 2 carbons, and 6 oxygens. So let's write the empirical formula, which would be CaH2, C2O6. So this is the empirical formula, but you may have someone ask you to name this. So in order to name this, let's look at the HCNO. If you guys are familiar with your polyatomic ions, you know that HCO3 -1 is bicarbonate. Okay, so in order to make this, the H2C2O6, look like this, what if we kind of took out a 2? In maths, you would kind of factor out a 2. So if we did this, it would be HCO3 with parentheses and a 2. So if we multiply this 2 by everything, we still get these same numbers. So 2 times 3 gives me 6 oxygens, 2 times the 1 carbon gives me 2, and the 2 times the 1 hydrogen gives me the 2 here. So we'll go ahead and put the calcium in front of this. So if you guys remember from naming compounds, calcium carries a positive 2 charge, and bicarbonate we said was a negative 1 charge. So these charges don't cancel out, so we switch them. So that's why the 2 gets put on the bicarbonate and the 1 goes on the calcium, but we don't write in a 1, so it's just CaHCO3 with parentheses 2. And the name of this would just simply be, and let's choose a different color for this, so we'll say calcium carbonate, not carbonate, bicarbonate. So let's do this. So calcium bicarbonate, and hopefully that helps.